Good afternoon, everyone. Welcome to the community talk on master data management and how to survive by Jens Villadsen. This session is for 20 minutes and 5 minutes at the last is for Q&A. So let's hear from Jens.
All right. Thank you very much. Welcome to this talk about how to survive. I cannot guarantee that you actually will survive and that what I'm presenting will actually apply to your case. But I can say that this algorithmic approach has proven to be useful for some of the cases where we engage. This is me in Rome. So my name is Jens Christian Villadsen. I'm the CTO at the Division of Digital Health in Trifork. And we operate across a couple of different countries and in all related to healthcare, of course, and most of those related to FHIR. And this will be my talk about master data management. So, big disclaimer, I'm a fanboy of the FHIR stack, so many of these learnings have been applied on top of the FHIR stack and also utilizes a lot of the functionality in there. Not to say that it cannot be employed in any other infrastructure, it's just where it is right now and where our learnings are taken from. Real-world setups contains a lot of data, and it also happens to contain a lot of duplicate data and deviations. It's not all countries that are as fortunate as we are in Denmark, where it flows with milk and honey and pristine data. That's just not the case in many setups, and we can also encourage deviations and duplicate of data that is not coherent and aligned in Denmark, but in Denmark we have a lot of central registries. So the learnings from this talk did not come from Denmark. Let me put it like that. There is a need whenever you have more than one data source for the same sort of real-life entity, or for the entities like practitioners, organizations, practitioner roles, locations, all that may come from several different data sources. And they may not all be aligned. So you can have practitioners from multiple data sources that do not actually tell the exact same story. There can be deviations across names, specialties, addresses, you name it. And that's just how it is. When I prepared this slideshow, I remembered that I recall I had heard a lot of this before, or something that relates really much to it. And I was correct. I attended a DevDays conference 2 years ago, right here, where Smile actually presented the whole thing about MDM linking, the master data management linking the different resources. That will not be of my focus. Defining master data. So here is the definition from Wikipedia. And big disclaimer, I will not, as I said, I will not talk about the linking part. I will just, for this part, just for the simplistic reasons, let's just assume that we have identifiers on the different file resources that we're going to merge. And they are sort of credible. We can trust them. And we can use that to link resources. If you look at the talk that was presented by Smile 2 years ago, you will hear that you can link based on basically everything. You don't need identifiers. You can link stuff based on heuristics like name comparison and so on. You can use AI for that. But let's not dive into that. Let's just say there are identifiers. And in our setup, it is mainly what we refer to commonly as plobber data. It's practitioners, locations, organizations, and practitioner roles. So plobber, easy to remember. So, yes, the problem is we have multiple data sources. We have several sources that provide the same kind of information that is not coherent, or it's at least not the same source of truth that we get. And it can go for, as mentioned, the plobber data, but also for patients especially. And it's an issue, because where is the source of truth? If there actually is one, what can you trust the most? So let's try to dive into an approach, at least the approach that we've sort of taken, because you can do sort of, I'll not call it the caveman approach, but you can merge data just saying, well, I trust this, I trust the source that came in latest based on identifiers. Then the latest will just be the truth. That's not really usable. You usually need to do something more intelligent than that. So following the law of Postal, being liberal in what you accept, let's just open the hatches. Let's just say if we have registry A and registry B that both have organizations, let's just accept that they can just pump in data, all the data that they have, and we'll make sure that we mark up, because we can add it in the way in on the interceptor server-side level, or we can, if we are in control of the integration that brings us the information, we'll just add the meta.source. That's a field in all FHIR resources. And we'll mark up where this came from, so we know where the data come from. You can consider a poor man's provenance. That's what we do. Or you could also generate a bunch of provenance resources. But poor man's provenance is sufficient for what we're going to do here. And we're going to accept duplicates and say, well, registry A should just be able to submit all its data, and we're perfectly fine with registry B sending in data as well, but they'll have different meta sources, so they will not be overriding each other's resources. They will, and you can sort of shard or segregate them into partitions if you fancy that, or you can add security mechanisms, making sure that actually the meta source is sort of a security field in terms of authorization, so that one source cannot override the other ones. Now, if we trust the identifier that was part of the source that comes in, as we do in this case, we can start linking the resources. So the organization from registry A and the organization from registry B, if they have the same identifier, or an overlap in amounts of identifiers, then we can link them together. And then once we have a linked set, basically a graph, you could say, or a bucket of information of the same entity, we can start generate a sort of constructed, and I'll call it constructed here throughout the slide. Probably shouldn't have, probably should have stick to golden, because that is actually a term when you start talking about master data management. Golden resources is the golden source of truth. But then, so you have your resource from registry A, you have your resource from registry B, and then you generate one server side. That'll be a combination of the two sources, and that is your golden resource. Now, what then happens? You end up having a Frankenstein model. So you just stitch this sort of together. So it can be that you trust the name more from registry A than from registry B. So if the name is present in the initial resource from registry A, then you take that. And if you do a, what's that called? A more sophisticated set, you can make this configuration base. So if you have the name from registry A, you do that, and if you don't, you do it from B. And then you basically end up stitching this golden record, which is a single coherent view. And the only way that you can modify the golden source, or the golden record, is to modify the sources. So what ends up? You end up having a potentially read-only model and a write-only model, and that is poop in some setups. And you end up having a read-only model and write-only model, it's the same sentence, and that is A+ in some setups. and to some, this will not really be FHIR kosher, you could say. It's converging into what is usually referred to as CQRS, because you have one model where you write and one model where you read. And it complicates it for clients that are to consume data. Okay, we have not much time. Okay, so we end up having golden resources, and we should go to the examples because, yeah, so all the data you have from your sources, let me rephrase that. It makes it a breeze making integrations because you can just pump in data and then you can aggregate it further on. Your integrations basically lives in isolation, and your golden resource can be recalculated by any time because whenever your data sources changes, you can just regenerate your new golden record. But let's go to the example because now you have all the clean data, or you have the golden resources that are clean. So essentially, you have Alice and you have Bob. They send in data. This is Alice's representation of data. This is Bob's representation of data. And then you throw it into your infrastructure, and then it looks like this. You basically have duplicates. Now, what you end up is you generate this golden variant of it, and as you can see, the golden fields are those that the server generates, but these fields are from one source, and this field is from another source. And the merging rules here are dictated by your infrastructure. And that is actually nice when you're Charlie here, and you would like to just give me the pristine source of truth, and that will be this one. But Charlie then also needs to understand, well, if he searches, which one is actually the correct one. So it makes it harder being a client because you'll suddenly have duplicates inside your infrastructure, while there's only one that is actually the what is deemed as the true representation of data. So how do you then modify it if you're not really satisfied with the two registries? Well, you can add sort of admin records where you can sort of override the behavior. So your friend of Charlie, who's Denise here, can sort of add yet another record, and if we trust this one more than the other ones, well, then the record of Charlie will actually go in here. So basically, you end up having computed resources available for your clients. So what has happened? You've actually increased complexity because you now have duplicate resources. But your source integrity is entirely retained because your registries are the only ones that can actually modify your data. Now you can question about the quality because you've constructed sort of your data. So, I mean, the quality will never be better than the total sum of the data that comes in. And if you're clever enough, you can recalculate your golden representation at any time. This is just a trivial case, actually, because you can end up having what is referred to as golden graphs. If you have golden practitioners and golden practitioner roles, shouldn't your practitioner roles then not also reference your golden practitioners? That's basically a whole other talk that we do not have time to go into because I only have like 2 minutes left. But that is an interesting side effect of starting to generate golden representations of your data. Now, our dear client Charlie, he now faced the setup where he needed to interface multiple representations of the same data, not just the golden, but also the sources. You can sort of, there are modifications to that if you make your infrastructure a bit more complex and basically take the setup where you aggregate your data and then just seed the golden representations downstream. It must be, yeah. But, as said, you will not survive. And making golden representations as these server-side generated records makes it easier to handle some data because you end up having abstractions that are basically merged based on what your business would like you to have. So you're actually sort of doing a shift left instead of having poor engineers, poor developers to make hard decisions of what kind of records that are correct. You can sort of extract that part, make that configurable, and hand it out to your business owners and say, hey, which sources do you actually give most credibility? How would you like to combine your records? And we'll just do just that and not making sort of technical decisions, which basically are business decisions. Time is more or less up now. And as said, even though you can do this and make these golden representations, you're actually just moving complexity around. So in some setups, it's way better not to use these constructed records that you can then reference from other clinical parts. It's actually better just to deal with source records and just actually get the best out of it. So it's really about moving complexity around. How's my time?
Good.
It's up.
Yes. Any questions?
Thanks, Jens. My name is Alex, and I have a question about what are some best practices that you recommend for creating a golden record should our use case require it? And can you give some examples of use cases where you may want to create a golden record and some where you may not?
I would say it depends. It depends on your circumstances. We have one setup where we needed to treat ingest of data from a spreadsheet on sort of equal behalf with something that we could get from another trustworthful registry. And once you start going down the master data management rabbit hole, it's hard to get out of. But it's hard. It's really hard to come with a general recommendation on when you want to do this. If you interface with a system complex where you have multiple different parties and no one really agrees hard on which is the most correct representation, then I would go for it. But it requires some complexity of your surroundings to start to add this kind of complexity to it to sort of survive.
Thanks for your talk. I was hoping you will address the elephant in the room. Like the patient record that I received from Alice, 10,000 observation is linked to it. The other patient that I received, it has another 20,000 observation linked to it. Mm-hmm. So now what to do with those? I want to run a single search query and return me all the observation for that single patient that we know they are the same patient. That's, to me, like elephant in the room.
You can do that. And if you rely on the FHIR stack, FHIR has a custom search modifier that's called MDM. And if you use that, you can cleverly enough expand your search. So whenever you reference one of your MDM managed resources, it will sort of identify the bucket of the resources that, so in some setups you can have as much as 10 or 20 different representations of your patient. And then it will actually join those IDs, and then you will search across that bucket of 10 different patients that are referenced across your different sources. So it's totally doable. They are obviously, so if you need to do that, your client does not need to be aware that you have 20 different representations of a patient. The server does, obviously, and it will do the pre-calculation of say, okay, this patient is actually 20 different instances, so I'm now going to search across 20 different instances. It's doable.
There is time for one last question. Anyone? I guess. Thanks for the talk and thanks for attending.